Hello students, so today I will cover the protection of carboxylic acid group as esters and anhydrides. So all of you know this carboxylic acid group RCOOH. This is quite reactive functional group due to the presence of one of this acidic hydrogen which is present over here that may react with any base, or the presence of this electrophilic center. So this some of the nucleophile may attack over this electrophilic center. So that's why we should protect. If we don't want to react this acidic functional group, then we have to protect this. So how can we protect it? Either we can convert this acidic functional group into esters or in a anhydride. So we can convert this RCOH group into esters in a many way, like it may be converted into methyl esters, it may be converted into ethyl esters, silyl esters, or tertiary butyl esters, allyl esters, or benzyl esters. It can be converted in the same way. It may be converted into various anhydrides. Okay, so now let's summarize the this protection and deprotection steps. So suppose so protection as and reagent used, deprotecting agent. Okay, so we can protect it as one of the way as esters. Okay, so first one, suppose either methyl esters or ethyl esters. So this RCOO, suppose I am writing here methyl ester. Okay, now so how can we prepare this methyl ester? By reacting this acid group by any methanol. Suppose methanol, H plus and methanol. Okay, so this is one of the way. And the deprotecting agent that we use is some acid can be used, acid hydrolysis can be done. So in presence of acid it can be deprotected. In the same way, we may convert it into, suppose we may convert into, this is methyl ester, this is methyl ester. In the same way, either ethyl ester or suppose the tertiary butyl ester, tertiary butyl ester. So in place of H, you may write the tertiary butyl group. So this is tertiary butyl ester. So how can we get this tertiary butyl group over here? So by in presence of isobutylene. So in presence of isobutylene we can get the tertiary butyl group over here. That can also be deprotected using some mild acid. Okay, so no doubt this conversion into this tertiary butyl ester or silyl ester or allyl ester, benzyl ester, this is much better in comparison to this methyl ester. Methyl ester needs some strong acid in comparison to this tertiary butyl or other ester. So they requires the mild acid for the conversion. Okay, so next one, trimethyl silyl ester. Trimethyl silyl ester. So this is RCOO, trimethyl silyl. So this is trimethyl silyl ester, and that can be, how can we get it? In presence of trimethylsilyl chloride. in presence of this trimethylsilyl chloride as a reagent we can use, and we may use some base, suppose in presence of pyridine. Okay, so this can be deprotected in presence of some fluoride source. Suppose HF can be used for its deprotection. In the same way, we can write the allyl ester, that is RCOO. In place of H, what we can write the allyl group. We can write the allyl group. So I have written this allyl group. So for this, to get this allyl group, we may use the allyl chloride. We may use allyl chloride. Okay. In presence of any base, and for this we can use a deprotecting in presence of acid. We can deprotect it. Similarly, benzyl ester. Benzyl ester. So so this is benzyl group. So I have added benzyl group over here. So this may be added benzyl group by using either benzyl alcohol in presence of this DCC we can use. And for its deprotection, we may use the acid can be used for its deprotection. Okay, so like this. Or for its deprotection, we can use this hydrogenolysis can be done, or H2PDC that can be used for its deprotection. Okay. Now, so these are as a esters. Similarly, we can convert this acid group into this anhydride. So anhydride or as anhydrides. Okay, so that is RCOO. So how can we get this anhydride? So we know that this anhydride that can be, we can get this anhydride by if we are reacting two molecules of acid, or either in presence of some acid chloride. So if we have a two molecule of acid, this can be formed in presence of two molecule of acid that can be used. Okay, so in presence of some dehydrating agent, suppose this P2O5, or we can use acid chloride may be used in presence of pyridine as a base. Okay, and that can be deprotected in presence of, suppose in presence of HCl, that can be deprotected. Okay, so this is the summary for the protection and deprotection of this carboxylic acid group. So let's see the mechanism for this one by one. So let's see the mechanism part. So first let's see this about this esters. Okay. Now one of the what I told you, that is methyl ester. Suppose if we have this methyl ester, then how can we prepare this methyl ester? Or how can we convert this carboxylic acid group into methyl ester? Using the alcohol. So if we have acid group, and this in presence of this H plus, this will get protonated. Okay, and in next step we have this alcohol as a nucleophile, so this will attack over this electrophilic center, positive charge is neutralized, and what we will get? OH over here, OH, okay, that is H2O, sorry, OH2, positive charge is present over here, okay, and positive charge. Okay. Now in next step, this proton transfer will occur. And now this removal of this H2O molecule. What we will get? RCOH plus, and this is OR, and finally the removal of this acid catalyst, and we will get the ROH, and this O, like this. So this acid is converted into this ester. So this reversible. This reaction is the reversible one, like this. So in the same way return, if we go in a backward direction, then that can be deprotected also. So this is a protection step. In the same way, we may deprotect it. Suppose for deprotection, suppose I write the steps are just, we can reverse these steps. So deprotection, if we see, let's write the deprotection step. Okay, so if we have this R, this is ester. Now how can we deprotect it? In presence of an acid. So first of all, what in the last step, this acid is present. So again we can go in a reverse way. So first this is protonated. This will get protonated. Positive charge will come over here. This is R group, and then in next step what will happen? H2O will get added as a nucleophile. H2O add over here. This will neutralize. Okay, so R, OH, and here OR, H2 plus. In next step what will happen? The proton transfer. Now proton transfer, this is converted into OH. Okay. Now in next step, removal of this ROH as a leaving group, and double bond OH, positive charge over here, and OH. And now removal of this acid as a catalyst, H plus. Okay. So like this. So we have got this acid again, so this is deprotected. So this is the mechanism. Now next come to the, suppose tertiary butyl ester. Let's come to the tertiary butyl ester. Tert butyl ester. Okay. So for this, how we get this tertiary butyl group? By using this isobutylene in presence of this H plus. Okay. So this will generate tertiary carbocation. Okay. So this will generate a tertiary carbocation. Okay, now in next step we have, suppose this acid group. Okay, Okay. So this is, we have got this tertiary butyl group over here, and this H plus that is removed from here, like this. Now, so how can we deprotect it? So if we see this deprotection, we have tertiary butyl ester. Now this is protonated, and what we will get, OH, positive charge. Next step, this bond will get broken, and again we will get the acid plus tertiary butyl carbocation, and here removal of one of the hydrogen proton, and we will get the tertiary butyl gas. So this formation of or removal of this tertiary butylene, it increases the entropy of reaction, or it favors this reaction. Now next one, you will see third one. Suppose this is the second one. You see this third one. Then we can write trimethyl silyl ester. Trimethyl silyl ester. Okay. So we have this RCOOH acid plus okay. Pyridine, which is present, or any base which is present in a reaction mixture, it will neutralize this acid formed, and we will get in next step, we will get this. Now this can be deprotected. So deprotection step using some fluoride source. So fluoride ion, it will form a strong bond with this silicon, and this bond being weaker in comparison to this silicon fluoride bond, and silicon oxygen bond will get broken, and we will get the acid back. We will get the acid back, and like this. Okay, so this is a simple mechanism. And the same way we can prepare a allyl esters and then phenyl esters. Or benzyl ester. So suppose if we have this benzyl ester, let's see this benzyl ester. Okay, so suppose if we have this benzyl ester in presence of this DCC, okay, and this in presence of, suppose we have okay. In next step, we have this group. So this will take over this electrophilic center, and this will get positive charge will get neutralized, and we will get Okay, now we have benzyl alcohol. So benzyl alcohol, this will attack this electrophilic center, this bond will get broken down and we will get C and this will come over. Okay. So this H will come over here and this is C double bond O. This bond we will get C double bond O and H and H. Okay, so we will get this dicyclohexyl urea DCU and plus we have got this RCO and this O. So we have got this benzyl ester and now that can be deprotected. So this can be deprotected. Deprotection can be done using this hydrogenolysis can be done. So this bond will get broken, this bond will get broken and here one of the H will come over here, another H, and what we will get RCO OH plus like this. So these are the different way that this carboxylic acid can be converted into esters. Now let's come to the anhydride. So one of the reaction that this acid can be converted into anhydride. Into anhydrides. So suppose if we have this acid and that can be reacted with another molecule of acid, and this H2O molecule will leave out. Okay. And what we will get? Anhydride. We will get the anhydride. So this the H2 which is removed, that can be taken out by the dehydrating agent, that is P2O5. In the same way, if we have this acid group, so this on reaction with acid chloride, so in presence of pyridine, so what will happen? So this will minus this HCl, and what we will get RCO. Okay, so this is the protection, simple protection step. Deprotection, if you will see the deprotection, then it can be deprotected using the acid HCl. We can easily deprotect it. Okay. Okay, so let's see some conversions now. Let's see some examples of this protection. Okay, now one of the examples, suppose if we have So this is one of the conversion. So let's see this conversion. So here if you will see, then this OH is acetylated to get here this acyl group, OCO, this is acetylated. Now if we have any, suppose if we react this molecule with acetic anhydride or acyl chloride, then what will happen? This OH will get acetylated, this COH will also get acetylated. So that's why both, if we do the acetylation, then this will also undergo acetylation, we will get this group, but this will also undergo acetylation. So that's why this should be, this COH, that should be protected. So what we should do, suppose we can protect it, we may protect it with any way, and suppose if I write the silyl ester, we can convert it into the COH group can be converted into trimethyl silyl ester. So suppose if we have okay, so using this and in presence of suppose some base, now so only the COH that would get protected. Okay, so this is protected, and next step what we can do, now the acetylation can be done. So suppose if we have acyl chloride, so this will now get protected, this will now get acetylation, and what we will get, this is OCOCH3. So we have converted this OH into this group. Now we can deprotect. We can deprotect this carboxylic acid group, and deprotection, as you know, this can be done using HF. So using HF, so this will get deprotected. The bond will break from here. Suppose this H will come over here, F will come over here, and we will get the desired product. We will get this desired product, OCOCH3 and COOH, like this. Okay, so this is one of the conversion. Now let's see another one. So let's see example number 2. Suppose here one of the double bond, here this COOH. Okay, and this can be converted. This can be converted into, suppose this can be converted into COOH. So now if we want to convert this carbonyl group into this alkene bond, okay, so what we can do, okay, so for this conversion, how can we convert this carbonyl into this group? So for this, all of you know, we can take some ylide. So in presence of ylide, so this oxygen will get removed, and we will get the CH2 over here. So, but if we have ylide, then ylide, in presence of ylide, the ylide will act as a base and it will abstract this H. Okay, ylide will act as a base and it will abstract this H. So, but we don't want to react this COH group. So that's why first of all this COH group, that should be protected. So let's protect first this COH group. So that can be protected. Again we can do we can use the silyl chloride. We can use the silyl chloride. So we have the protection, okay. So this is converted into silyl ester. Now that can be treated with elide. That can be converted to elide. Okay. So final step, in presence of HF, that can be deprotected. So this bond will get broken, here H will come, here F will come, and you will get the desired product this way. Okay, so this is the conversion. Now let's see another example. Okay, another example. Suppose if we have this molecule, okay, and if we want to convert it into so what is the difference here? We have to bring one of the methyl group over here. So how can we bring one of the methyl group over here? So if we remove one of the hydrogen, if we remove one of the acidic hydrogen from here, and then after that we can do the nucleophilic substitution. Okay, so this will act as a nucleophile, and that can attack over the methyl halide. So and we can get this one. Okay, so suppose if we remove one of the base from here, one of the proton from here by using some base, then what will happen? This proton will get removed, and this one of the acidic hydrogen which is present in the carboxylic group, that will also be removed. So what we should do, first of all, we should protect this carboxylic acid group so that this acidic hydrogen could not be removed by the base. So let's first protect it. So again, suppose I am converting it into the silyl ester. Okay, and what we will get? Convert this one into the next. So this is being converted into silyl ester. Now this is protected. Okay, now this is protected, and what we can do now, we can now extract the acidic hydrogen using sodium iodide. So one of this acidic hydrogen is present over here. Okay, sodium hydride act as a base, and this can take this acidic hydrogen, negative charge will come over here, and what we will get? We will get negative charge over here. It will act as now nucleophile, and in next step any methyl halide. So this will so SN2 reaction will occur, and we will get one of the desired product, and finally that can be deprotected using either HF, or we can use a tertiary butadiene or and we can use a tetrabutyl ammonium fluoride as a fluoride source. So this bond will get broken. Here we will get H, here we will get F, and we will get the desired product. So finally we will get this desired product. Okay, so this is the protection about the carboxylic acid group. Okay, thank you.